So here's how that'll work too.
I just made you be quiet.
Unmuted?
Feedback.
And are we getting any kind of feedback? The camera's going nuts too.
Here, I'll just leave computer audio. There. Better.
Cool, cool, cool. Awesome. Yeah, that's actually not bad. Okay, cool.
And then I'll share that screen in the queue here.
Awesome. Awesome.
Either pro pineapple, anti pineapple, or anti
Cool.
And then you were you're recording the thing as well.
Yep. Well, so yeah, I'm recording it, and at the same time, I'm streaming it on Twitch. It lives out on Twitch for 2 weeks, and then it drops off. And then I, at some point, upload it to YouTube. Cool. And then as far as like order of things, I'll jump in there and just introduce the group, you know, say what's up. And then whenever you're ready, if you're good, we can pop right into it.
Cool. Sounds good. I didn't know how much content to prepare for, so if things are getting a little long in the tooth, just flag me and be like, shut up.
Yeah, I mean, the general rule of thumb I say is like, you know, I typically say these things are around 2 hours. I don't expect anybody to talk for longer than 45 minutes. If you do go over, that's totally fine. The only other thing I'd say is like, most people's attention span is around 30.
Yep. Yep,
So-
okay, cool. What you talking about?
I'm gonna give you a 5 when it's 45 minutes.
Okay.
After you start.
Perfect.
Okay.
Love it. Oh, that was so better reading yourself now. Oh, yeah. How do I do it? Yeah. It takes a bit. There you go. Oh my gosh, you could pull it up. Well, yeah, like in one motion, not like the restage thing. Well,
You have like, social media, website, LinkedIn, or anything you want me to
sure, yeah, LinkedIn is just Gray Dash Lovelace, I believe. I can grab the link for it if you want. We're gonna have this repo that's available for everyone as well. How helpful it will be, we will see, but yeah, the Source Allies website is always good as well.
Yeah, it is you. Sweet, very awesome.
There's not a lot of Gray Lovelaces out there.
Yeah.
It has pretty solid SEO.
Yeah. Okay, cool. We'll do. Yeah, and then I don't know. I probably can just read it from there, but like I'll try to grab the
Yeah, and if you want,
because you can join Slack and dump it in as
yes,
well.
yeah, here, I'll do that real quick.
Okay, cool.
This like UI option.
Yeah, create the account. Yeah, well, I'm just like, I already have the account, I'll just say. Continue. You're in.
Yeah, you're in. Because there's a difference between a Slack account and a Google account.
Yeah.
Yeah.
Well, like you think you just say continue, that's the account you're using. Skip all that for now.
Oh, there we go, yeah. Hey.
You got custom emails, I have one for you.
Okay, kill that whole thing. Grab that. No, that's not the right thing. No.
There you go.
Just want me to Slack this directly to you or throw it in the general?
You can throw it in the general right there. That'll be perfect. Awesome. What is that? It's meeting. Live streamed. Sure.
Session. Session based. though.
I really love that you guys can see everything. It's really solid.
I don't know why it's not working.
We're watching. Yeah, and if you couldn't see, you would just be analyzing what you're doing. So. I don't know what
Okay, now I'm gonna go back. I'll be back.
We'll hold this spot for you.
I appreciate that.
Yeah.
How's everybody's September going? Good.
Yeah. Yeah, that's not summer. Oh, and it rained last night. Yeah. My weather, one of the weather station thing, apparently it stopped recording how much rainfall. When I figure out what. Well, it's recording everything else, stopping right.
Hey, good, Travis.
No, there's so much stuff.
So I meant to get back to you, but definitely, yeah, if you want to talk next, October, that'd be good.
Say that when I was in that talk last time,
Mhm.
I put the talk together like an hour,
Mhm.
but it turned out really good, so.
Awesome. Very cool. Yeah, sometimes those surprisingly work.
So you walk right by the pizza.
Yeah. it's called- Put more-
Gotta pay the pizza.
You slice it.
Welcome.
So has anybody hit up any conferences this year or anything on your radar that you're looking forward to? Or-
About today's was Tuesday, Friday. There's
No, unfortunately, no.
anything you like.
I have not had like the time to just get out and look. So yeah, that I used to look all the time, that has kind of fallen off, so yeah, I don't know what's going on anymore. I'm out of the loop.
Well, don't go like that, so that gets.
See the most recent. Or added inside the news. Yeah. You like going to do laundry?
No.
We're wearing.
Stop at Bath and Body Works on the way here.
Rolled.
Really smelling.
Ears and senses.
Oh, so you just smell much. Oh, yeah.
I don't think that.
Then the hot topics, you can smell it. Oh, okay, yeah, sure.
I work at startup. None of them were in mom.
Hey, I'm having a coffee with Samantha tomorrow. Yeah. After like 5 minutes. I can't get her for coffee, but not to chat. I'm cool, so.
Very good.
Yeah. There you go. So aggressive. She got down and talked to me and. Right, oh, right. Oh, yeah, that's right, you came over and introduced her. She stayed there for a while. What's interesting is right after we introduced her, in October, we just finished talking to Minute about how we really great, a little hierarchy. It was like, with the software development, but also had a passion for UX, so they could be on really UX work, but they didn't put them per kind of people, they could also be involved. And we're like, we could hire like class training instead of like one full-time UX person, and we get like 3 of those people that maybe become better covered. Oh, well, that's when she sat down and I heard. So is it Rob? Great. We got the agencies then, like. First. Stop, I'm just sorry. Yeah, better. Oh. I think it was like you and him. Oh. No prediction. Good, how are you? Uber. I do, yeah. I don't know that. So I do make sure of like architecture design works, vision. Used to do a lot of those Spring Boot, custom web app development. I've been moving out more to like scaling lines. It's going pretty well. Similar to one I just put it on the work outline. So see, well, hopefully. It's like, why is it? So. Let's put it out into like some real world. So I run on various some. Yeah. So the part I find like those or or do you do? Yeah. A lot of people, I don't just it's tough. So when you are doing things that are more related to numbers, it's easier. So if you are working with a instead of like a text, it's fairly easy to just be like, okay, I have this like static thing that's already embedded in here, and then I generate a new thing, and I try to ship over the forms, check that it's the right items or it's from the place source. I've not had to do that quite yet, just because of the scope of some of the demos. However, I kind of thought through some of that process. The text would be really well, because it will show that everywhere slightly different type of words every day. So it's basically we're going to do another model for like some sentiment analysis sometimes. Yeah, I don't know. It's a little tough. So we got all just every day. Yeah. It's great. Yeah, it's interesting. It's something that's there's a how long you were we're retrieving that. Okay, so that's what that demo was on. I think that's another the one that the web geeks did 1 or 2 months ago. Yeah, it's similar. But it's using that embedded model and saying the contents of listening to language model and this content this question. It's not there are a couple of subversions of them where token on very smart, and you can't feed in things because there and then after the question. Nesting where you keep doing that and summarizing and so you can get a chunk of it.
The longest time, still.
Where you were just like,
It's just.
they're quite senior.
So they, starts to kind of approach that. There's like a handful of it out, like your search, what we started doing is actually. That's what they do. You can do a lot of different things if you're like.
It's like right here, and I should have been more descriptive.
It's like a notch. But that actually helped me sort of, okay, here's kind of the scope. So complex, here's some different. More.
I think it will be that's mine. Because there's one of them already
Yeah, so it's funny that you say that, it's really, those, cause mine, the value proposition is like.
Really?
Yeah, cause like some of those they're going for a certain value. Right, yeah. Medium. And I know. It seems that it's like an analysis. You don't need to write it in on the funding at the time. But the process automation, very specific information that is specific to you. It's like systematically we can sort of there are drinks.
And restrooms, fall left out.
Wi-Fi something.
But yeah, like I said, we'll probably kick off in, like, I don't know, maybe 2 to 3 minutes. So it's a, you good?
Yeah.
Okay, awesome.
So like a. Anthony.
Oh, like a huddle?
Yeah.
Yeah, we can do a quick scrum.
Thank you, Mike. Rugby, but it's. Yeah. All right.
Cool. So I will kick us off.
Okay.
Just make sure sound is good. And
Yeah.
I'm gonna test the sound. Yep. Awesome.
You just have to be released. Appreciate it.
Yeah, we can do it.
Yes.
Good idea to send your mom.
Okay, cool. All right, y'all, I'll kick us off. So just so everybody knows, at the same time that we are talking, this event tonight is being recorded. It's streamed on Twitch, twitch.com/DSM Web Geeks. And eventually, as it's recorded, I'll have this video. I will at some point in time upload it to a YouTube page that I swear exists. Or DSM Web Geeks. Just contains no video instead, but I'm all sitting on the left. Okay, well, welcome out. Thank you all for coming. If you are unfamiliar with what DSM Web Geeks is or is user.under, we are a user group that has been organizing and putting on events for a little over the last 15 years. Our main focus is within software development, which is a huge broad topic. We talk about as pretty much anything under the sun that fits within that realm space. Design, content, back end, front end, whatever it is, we try to craft events around those topics with varied formats. You know, sometimes it'll just be a speaking event, sometimes it'll be a round table, sometimes it'll be a hands-on coding, kind of like hackathon event. If any of that interests you and you would love to either join up and come to more of our events, that's what we need to do. Just find us on either dsmwebgeeks.com, our website. Hit us up on there's a Facebook page, a Twitter feed, there's Eventbrite and meetup.com, and we'll start posting on LinkedIn as well. Any one of those channels, if they don't find you, let us know and we'll get on a different channels. We can get this information out there. If by chance you are interested in maybe helping organize, I organize along with Ben over here. He helps out. And if that's something that you might be into, maybe to like hone your skills and doing this kind of stuff, or just a volunteer, or whatever. More the merrier, we welcome. We would love more help on putting on events and organizing these events and all that stuff. When we do have events, we try our hardest to make it the second Monday of every month. We kind of try to hit that like clock. In the recent times, we've been kind of bouncing back and forth between Source Allies and East Village, the company called Logic. It's an ad agency, really, really sweet space downtown with ample parking. We are there sometimes too. So watch for new events coming out. Like I said, dsmwebgeeks.com, Facebook, Eventbrite, soon to be LinkedIn. Well, yeah, if you have any questions about Web Geeks, hit me up or Ben over there, like I said. And what might also be kind of nice, if you are interested, there is a thing called DSM Web Geeks, which is, it tries to kind of like bridge the gap between all the user groups in the morning. We have a pretty fairly active or a large community in our Slack channel. If that is something you would like to jump into, the easiest way to do it, there's probably other ways, the easiest way I found to do it is just hit me up and I'll have you just dump your email right there in the app and it'll just send you a link. That's easy, but I don't know any other way. Maybe you let me know. So that's good. Then we're just about for fast. Sure.
First of all, welcome everybody. Thank you so much for being here. My name is Ben, and I'm on teammate services here at Source Allies. We're so happy to have Web Geeks here tonight. We host user groups throughout the year. little over a year and a half ago, I started here at Source, and when I did, I started going to user groups in the area, and I connected with Justin and the Web Geeks. I think the most out of all these groups that I went to. So I have been a public educator in the past. Event planning was part of my wheelhouse, so I wanted to give back to the tech community. That's why Justin and I collaborate on setting some of these up. So first of all and foremost, thank you for being here. To tell you a little bit about Source Allies and what we do, we're a software development consultancy here in Urbandale. Basically, our partners hire us to be the experts to work with their teams to fix the particular most difficult problem that maybe their teams can't solve on their own. I'm very proud to be part of a team of over 100 software developers, teammate services folks here at Source. If you're interested in hearing more about what we do and opportunities available, hit me up either here or on LinkedIn if you have any talk with me. Thanks.
Awesome, awesome. So tonight, Gray is going to present to us. If you have any troubles hearing or whatever, let us know. After we'll maybe do QA, I don't know, and then we'll wrap it up. You all good? You need anything else?
I feel fantastic.
Okay, cool, awesome. The only thing I'd say is like try to project.
I've never been accused of being quiet.
Awesome. Awesome. Thank you.
Cool. All right. Like I said, my name is Gray Lovelace. I am one of the software consultants here at Source Allies. Today, we are going to be going on a journey together. I hesitate to call it a demo. I kind of wrote this in a feverish dream from like 8 to 12 p.m. last night. So if you have any questions, thoughts, comments, concerns as we're going through it, please just like yell them out. We can absolutely take a swerve in the middle of this if we want to, if what is on here is not helpful to anybody. Specifically what we will be doing, I try to go for the record of most hyphens and words in a GitHub repository name right here. But this is a Spring Boot GraphQL demo. Specifically, this will be using as many of the like out-of-the-box Spring Boot libraries as you can. I know that there are like 17 or 18 other ones that you can try and use if you want to, but these are the ones we're going to use. And if you don't know a lot about GraphQL, we'll kind of touch on that a little bit at the beginning as well, just so you get a little bit familiar with it. But yeah, before we jump in, any questions? Everyone feeling good? Awesome. I will not be able to watch the chat on Zoom, so if anyone has any questions, you got me? Awesome. Thank you very much. Cool. So let's get started. This repository right here is, let me see if I can get rid of this guy. Beautiful. This repository is a lot of commented out code right now. By the end of this, hopefully we will have uncommented like 80% of this code and have a working demo. But let's just take a quick little tour of what's going on. So what I did at 8 p.m. last night is I went to Spring Initializer or start.spring.io. If anyone's familiar with this website, awesome. But this is where you go when you start basically any kind of like proof of concept Spring project. You get to choose a bunch of different libraries. You get to choose what kind of project you're building. Are you using Gradle? Are you using Maven, Java, Kotlin, all sorts of fun stuff, and give it group names and choose what Java version you're using. And then what it does is it zips that all up in a project directory, gives you the zip file, and then you just extract that on your local, and that's when you can start building right away. There are lots of different dependencies that are just built in that you can choose from that get you up and running off the ground. I'm not going to build this right now because that would be very boring for all of you. So I did that last night. What you can see is that there is a picture of what it looked like right before I hit extract in the repo. And there's a link to that in the README right here. So if anyone's interested in doing this from scratch themselves, great, that is where I would start. So what does the project look like once we've actually kind of extracted all of that? Where are the important bits that we're going to focus on today? So let's look at our main application, some where our configs are that we're going to be playing with, as well as where are our actual GraphQL files that do all of GraphQL magic that we care about. So to VS Code, where all fun things happen. Here is our repository right here. Is this a good size? Can everyone read it?
Yeah.
Excellent. So first things first, where's our main application? When I run my Gradle command to run my Spring Boot, what's that going to look like? Well, if I go to source main Java, there is this demo application that is aptly named in here. It has public static void main string args, which if you're familiar with Java is where you're going to start your program. And we have Spring application run. I'm not going to go into a lot of how Spring Boot works. This is going to be a little bit more of an advanced Spring Boot plus GraphQL thing because we got a lot to get through here. But this is where we start out. Now, where are all of our configurations that we're going to play with? If you're familiar with Spring, you know in our source main resources, we have our application YAML here. You will usually end up with like 17 of these files, depending on how many environments you're going to have over time. However, we are going to focus on one right now because we're only going to be running on my local. The only thing that we have configured to start out here is just some logging levels. So logging level, our root is going to be info con.example, which is our very descriptive package name of our project right here. It's going to be debug level. And then flyway, which I'll get to in a little bit, is going to be info. Everything else is going to be used for stuff in the future that we're going to get to. And yeah, that's it. So very, very minimal config so far. When we start this up, it's going to run on port 8080 by default. And then our GraphQL files. So let's go look at where those are. Same place as our application YAML. You will see in here we have resources. And then we got a GraphQL directory out of the box when I downloaded from start.spring.io. And in here is where all of our different GraphQL schema files are going to live. I'm not going to open them because I don't want to spoil any surprises quite yet. We'll get there. But we have some example queries in here that will cover some of our things that we're going to build a little bit later on. And we have some simple versions of stuff and then some more complicated versions of stuff that we're going to open up and explore as time goes on. So that's where everything lives. Before we start digging into GraphQL schemas, everyone feeling good so far?
I have one question. Could you go back to Viz Code?
Absolutely.
Why is it backwards? Why is your Explorer on the wrong side of the screen?
Backwards is a very opinionated word. No, we had this argument like half an hour ago.
Oh, sorry.
I like it on the right because when I toggle that being there, I don't have to change where I'm looking for my files.
Yeah, I think it too. Yeah.
I know, I am a toddler, especially when I'm zoomed up like 7 times like I am right now.
I dig it.
Yeah. I'm sorry, if you can't trust me anymore. I understand. Okay. Cool. So, any other questions? Excellent question.
Great.
Yeah. Cool. So, GraphQL. Everyone kind of show of hands. People familiar with GraphQL, like writing the schemas, kind of how they work. Okay, we have some familiarity here, like 50, 60%. Awesome. So GraphQL is kind of some people would say the next evolution after REST. If you ever want to hear someone talk about GraphQL for a long time and its tenants, Paul, raise your hand, Paul. He's a great person to ask. He will talk to you forever about GraphQL. So GraphQL is kind of, it's interesting where REST has all of the different REST HTTP codes that you're using, and it has a fairly standard setup there. We kind of go back to the SOAP days with GraphQL, if anyone used SOAP, where everything's a post. And it has kind of its own paradigm of how it's communicating. You don't really return response error codes, which we'll get into later. Like everything is kind of set up where you're always returning a JSON payload. It has data, and then it has like info that you try to give it, or it has errors about being able to retrieve the info you tried to give it, or you tried to retrieve from it. But the really cool thing about it is that there is a lot more consumer agency than there is in REST. And the consumer can define what they want you to spend time actually getting, or what they want to like have come over the network to them, because all of that costs, especially when you start operating at very large scales, like enterprises and a lot of the clients that we work with do. So if you haven't seen what a query looks like, honestly, let's just hop over to Insomnia. If you guys aren't familiar with Insomnia, it is very similar to Postman. If you aren't familiar with Postman, it is something you use to make REST calls locally. So you will see everything kind of looks like this. You have a URL that you're going to hit. You usually have some kind of like auth or a post body or something that you're sending. In the case of GraphQL, it's going to be your GraphQL query or a mutation or a couple of other things that I'll get into here. And then you'll have some kind of response. In this case, this is a very, very simple query. It's query sample. Sample is the name of our query. You'll see that a couple of times. You usually have like a wrapper and then the thing that's actually calling it in the middle. And then we are saying, when I call sample, I want it to provide me the value inside. This is not showing us super well right now. We'll get to it a little bit more when we get to more complicated objects. So if I were to run this right now, my server's not running, it's gonna give me a terrible bad error, which is expected. That's great, it's working like we want it to. So let's go look and see when we run our app, what's it going to start serving up for us. What we have here is a very, very simple GraphQL schema. And we are defining our queries right here, and we are defining any types that are going to come back from our queries right here. So you can see we have a type of item. It is very simple. It just has one value inside, and that value is going to be an integer of some kind. And then the queries are how we're going to interact with all of those types that we've defined. So we have sample, which is going to be one query that gives us back an array or a list or a collection of item objects. And then we have sample with params, which is going to do the same thing, but we're going to be able to pass in the divisor, and it will only give us back values that are that evenly divide by a divisor. All right, and then we're just going to implement this together so we kind of get a good feel of how things are going. And then once we implement that together, you guys don't have to watch me code a lot anymore. Everything's already kind of coded, and I'll just uncomment it and show you where all the fun bits are. Sound good? Cool. So, like I said, this is our definition right here. And the really cool thing about the Spring Boot kind of ecosystem working with GraphQL that I enjoy is this is not documentation, this is functional. So I've done a bunch of documentation, I've done a bunch of Swagger, I've done a bunch of everything that you can kind of name that's all going to be like an afterthought and does not actually need to match your code in any way to exist. This needs to match your code. If you don't have something defined here, it's not going to serve it up over the GraphQL endpoint for you, which is really nice. So we are going to go implement the code behind this really quick. First things first, let's just go start up our application. So this is an alias I have. It's just running the Gradle wrapper boot run command behind the scenes, but I'm not going to type that 17 times tonight. So we have started our demo application in 2 seconds. We are good to go. If I go here to Insomnia and I hit the default GraphQL endpoint for our Spring app, which is just /GraphQL, I should get back that we did not get back anything from the path sample, which is the query that we tried to run. So this is already a good insight into how GraphQL behaves. We got back a 200 okay, so we didn't get back any kind of error code, even though the query that we requested doesn't even exist. But what we did get back is an errors array that actually described a message, the path that we tried to call, and any kind of extension saying what kind of error it was. So again, GraphQL weird in that you're going to handle all of your errors in your data with those 200 response codes. You are not going to really get back a lot of error codes when you're doing this, unless it didn't even get to the whole part where GraphQL exists. So that doesn't work. Awesome. Let's stop it. Let's go back and let's start to actually implement this, shall we? So I have what's called a controller. You guys don't know what a controller is. That is a fairly simple class in Spring Boot. We annotated it with that controller, so it spins it up, adds it to the bean pool. I'm not going to go into the bean pool a lot right now either, but that's a Spring Boot term, just basically a bunch of instantiated classes that are already ready for you to go to either do dependency injection or just like serve up different things for you. So we are saying that our demo controller class is a controller. It's going to serve up different like REST endpoints for us. And in this case, we don't have any REST endpoints set up or any GraphQL query mapping set up. What we do have is we have a record, which is a very, very simple class, and it looks pretty familiar. We have an item with a value inside, matching our GraphQL schema. And what we have here is just a bunch of items that we've made with ranges 1 through 10 of values inside. So this is just using the Stream API to instantiate 10 items for us and throw them in a list so we can use that for some of our examples. Sound good? Okay, so we are going to start by making a quick method. And this method is just going to return all of the items that we have here. So public list item. Sample, because it's going to match the name of our query that we defined in sample queries. So sample, this is the one we're working on right now. Oops. And we are going to just say return items, which again is defined right here. So this will work for us. This is great. However, it has no idea that it's related to GraphQL whatsoever. So this is when we start leveraging all of our many and abundant annotations in Spring Boot. So query mapping is the name of the one that we want. So anytime, oh man, All right, query mapping is the name of the one we want, and you can see that this comes from the Spring Framework GraphQL data method annotation query mapping setup here. This is just going to let it know this is a query that I have defined. It should match something in my GraphQL schema that you have already consumed from the predefined place when you start up. Marry those two things together. I don't need to do anything else. So let's start it up and see what happens. All right, we're good to go. Insomnia, I'm going to send, and what you can see is we get back a bunch of different sample objects. So everything's going to be wrapped in this top level data object. Data and errors are sibling objects in a GraphQL response. And inside here, you're going to have the name of whatever query that you just ran. So sample, technically in more advanced cases, you can run multiple queries at a time. It will return you multiple payloads. I have not done a lot of that so far, but it is a possibility throughout this spec. But sample here returns us a list of item objects. Each object has a value inside, and you can see that they are numbered 1 through 9 there. Cool. Yep. Feel good? All right, so let's start doing some fun things with that, shall we? Really quick, I'm going to go back to my README and make sure I didn't jump over anything. Okay, yeah, so GraphQL schema just in general. We talked about a type, which was our item, which is basically just kind of a class definition that we were working with. We talked about our query, which is how we're going to interact with those. There are other things that we're going to hit a little bit more on later called mutations, which is when you call one of those, you would expect to change data, similar to calling like a post or a patch in REST. Yes.
Just, you would find that item only in the GraphQL file. You don't have like an item class floating around somewhere.
I do actually. So the neat thing that I was kind of talking about with the GraphQL portion of Spring Boot package is that, like I said, it's functional. So I have this defined. This is kind of making its own GraphQL item class behind the scenes that it's going to use to populate and give back its response. I do have one that looks identical inside my controller here, just so you can kind of see everything. So it's using a record, but that's just shorthand in newer Java for a class with a bunch of getters and setters that have a value on them. So yep, I do have an analog in a Java class or a Java record that I'm using to create these things. But that leads me really well into my next item here. So next item is that I'm returning an object in Java called an item. It doesn't care, is the kind of neat thing. We're going to call it neat. I've heard other people call it dangerous or misleading, but we're going to call it neat here. So what happens is there is a particular type of order that it tries to resolve everything in at the GraphQL layer after you have returned an object from your controller method that you've mapped to that query, right? So once it gets back something, so in this case, we said that we are going to give it in our schema a list of item objects. What I've given it back at the end inside this controller, I gave it back a list of item objects, but it doesn't care. It knows that I gave it back a list of objects. Then what it does is for every object that I got back, it tries to then parse the rest of the GraphQL schema for me. And it resolves everything one of basically 2 ways. The first way, or let's say the last way, the default way that it's going to fall back to is it's going to look for a getter on whatever object that I'm iterating over. So that's what you see happening here. The item class has a get value that's generated behind the scenes, or just a value in the case of a record, it'll kind of be flexible for you. And when I hand it back a list of items, the next thing that GraphQL is doing or Spring Boot is doing behind the scenes, it is saying, I expect to get back a bunch of objects that look like this. Look for something called value on the object I'm like currently iterating over. All right. I'm going to explain this a little better I'm going to show you how you can kind of hotwire this in just a second if you want to, because that's the default. And the default is what we see happening right now. However, you can kind of hijack that with something called schema mappings. All right, so let's go ahead and do that. If I go back to our controller, I'm just going to close some of these guys that we don't care about right now. If we go back to our controller, we can set up what's called a schema mapping. And schema mapping is, of course, another annotation in Java. And what it expects is if I have a method, you can do this all through like actually setting up some configuration here, but naming it works fine as well. If I have a method that is named the same as the field I'm going to be looking for, which in this case is value, right? And it accepts the parent object that I'm going to be iterating over, which in this case is item, as a parameter. What I can do, oops, it needs to return the right type of value. I can kind of hijack that and basically say, every time I have an item object and you were looking for value on it, don't go use the getter. Instead, use whatever logic is in this schema mapping. All right. Seems a little weird right now, but it's going to be really, really helpful later on, especially when we get to working with like large groups of objects. But right here, right now, we're returning 1 through, I think, 9 for all of our things. Instead, we're just going to say return 100. Now what I should see, if I were to restart this, is when I call, I get back the same number of objects. However, they are all going to have a value of 100 instead. All right, a little weird. I can take that and I can take the object that I'm iterating over and like add 5 to it if I want to mutate it in some way. That's how you would normally use this, is you mutate the data. Or if you wanted to be like, it's a greeting, you get back a bunch of names and you're like, you append hello to the beginning of the name, something along those lines. Those are all pretty simple versions of what you could be doing there. But that is what using a schema mapping looks like to kind of hijack, instead of just using the normal getter, I want to use different logic there instead. It's a little bit of a weird concept. Any questions or thoughts on that one at all? Yes.
So if you wanted to like add 5 or something to each of the existing values, what would the syntax for that look like?
Let's do it. I love that question. So I'm going to take the item I'm currently iterating over. This accepts an item object. So item is going to reference whatever thing I'm returning at the current time, right? So I'm going to take item dot value, not there though, dot value plus 5. All right, now if we send, we get back 6 through 14. Yep, absolutely. Does that help? Awesome. Any other things? Like I said, this is like the biggest thing that whenever I work with people on this particular project, that's the thing that like always goes in circles for a little while. So if you think of anything else later on, let me know. We can always hit it again.
So it's going to take precedent over query mapping every time.
So the query mapping is a different thing. So the query mapping is returning a list of the things I'm currently like iterating over. But it is going to take precedent over the default behavior, which would be invoking the getter for that particular thing. Yep. And I do call that out in the README as well right here. Resolving schema mappings, doesn't matter what object is returned, it does not care, but it will continue to use the same pattern of, do I have a schema mapping that matches and takes the current object as a parameter? And then if there's not one of those, it uses the getter method on the object it's currently in. Awesome.
Does it have validation on, like, if it wasn't called value, it was called value 2 or something?
Which part called
Like
value 2?
moving startup or something, yeah.
So it will explode. Yeah. So this wouldn't explode. If I called like this value 2, it would just be like, oh, I didn't find a schema mapping, I would resolve back to the getter. However, you do bring up an excellent point that we should hit really quick. Validation on what you're returning. Not only is this functional in a few other ways I'm going to show you in a second, but it's also functional in that it will automatically validate that you are matching the schema that you have provided and you have defined here. So you see some exclamation points in different places. Exclamation points mean it's a required object in a schema. That can be on defining like the parameters being passed in, or it can be on when you are returning things. So when you're setting up your contract for all of your queries and your mutations. In this case, what I'm saying is when I call sample, you will either get back an error or you will get back an array of some kind. And that array will be filled with item objects. One caveat to that is that, you know what, I'll hit that in a second. But this is saying you will get back an array, no matter what. So if I go here and I say, you know what, don't return items, return null, because this is Java, I can do what I want. When I do this, what we should see is that the GraphQL police hijack my thing and say, no, you get an error as a consumer because the person who implemented this API did not like behave to their own schema specifications. So if I send now, look at that, an error. Field of path sample was declared as a non-null type, but the code involved in retrieving data has wrongly returned a null value array. Yeah, that's what it says. So that is it doing its own validation on its side. And that can go like as deep as you want. There's very specific validation that's going to happen there. Now let me go revisit the one thing I was going to say that's like a weird caveat. Arrays are weird. Or like collections are weird in GraphQL, and that I am saying the collection itself must be populated when or must exist when I put a exclamation point after the square brackets. So I must return a collection object of some kind. However, because item doesn't have an exclamation point on it, that can be filled with everything in that collection is either going to be an instance of an item object or it's going to be a null. And I don't love returning a list full of nulls. So what I would probably do here, and what we should do if we're good people, is throw an exclamation point on item as well. So it knows it's not necessarily going to return any items inside the array, but it's never going to return you a null as one of the items in the array. Make sense? Okay, cool. That's a weird one. That's bitten a couple of times. Just remember that whenever you start digging into this on your own time, which I'm sure all of you will. Okay, so let's kind of do the same thing down here. And any questions before we go on to starting to pass in some parameters with our queries? Doing some really fun stuff. Okay.
Just a comment, on my team, a lot of times we have an exclamation point in their object, but not in the array. We will
Okay.
allow null back,
Mhm.
but we won't allow null inside of the array.
Gotcha. Yep, absolutely. And just being specific with what you want that to be defined as is always a good, like, always ask yourself that question, do I want to allow a null here? If the answer is no, throw an exclamation point on it. And if you don't behave that way, it'll let you know. Okay, so it makes a good point that I should make my thing I'm declaring here be required as well. So we are going to now implement sample with parameters or sample with params. And again, this is going to let someone pass in a divisor, and then we are only going to give back the items that can be divided evenly by that divisor. So let's just say we're going to get back all even ones. We're going to pass in a divisor of 2. Okay, so let's go implement, shall we? We are going to get rid of this schema mapping for right now because it will break everything I'm about to do. And we are going to say another query mapping right here. It is again going to be fairly easy. We're going to public, we're going to say it's going to return a list of items again, and it is going to match the name that we gave the other one. So sample with params. Okay, here we are going to put in our divisor that we care about. So int divisor. It is always going to be populated, so we don't really need to worry about big N versus little n or capital N versus not capital N, because it's Java. But what we are going to do is tell GraphQL that we expect this to be an argument in our GraphQL stuff. And that also comes from the same GraphQL data method annotation setup here. This is just angry at me because I'm not actually returning anything yet. So if I were to return null, that can go away, and then we can talk about things that we need to do here. And we can unbreak our old one. Cool. Nope, that's not the list. Items. Awesome. So sample with params, we are getting the divisor back in. We're just going to do a little bit of Java magic here. Say items dot stream dot filter item. We're going to say item dot value is divided by divisor equals 0. Dot to list, because you have to collect back to a list. All right. So what this should do is actually implement our logic for only give me back the item values where the divisor divides evenly. Okay. So let's start this. Cool. And then let's double check that sample works again now that we unbroke it. Great, looks awesome. And then if we come to sample with params, you can see here, we have a few different things going on. Our query got a little bit more complicated. Is this big enough? Can we see it? Awesome. All right, so query, sample, honestly, the thing that comes after query here, like I said, is just a wrapper. It is whatever name I want for it. It can be Grace query, it does not matter. But what we're defining in here is all of the different query variables that we want to be able to pass in kind of using this JSON object down here. So this is kind of the consumer wrapper, if you will. And then everything inside that wrapper is going to be the actual query that's defined in our schema that we are consuming. So sample with params is expecting a divisor in. We're going to give it our divisor that we are putting in our query variables down here. And then we want to get out the value object from the array that comes back, or from the expected return from our sample with params. So let's go ahead and do that. In this case, let's make our divisor 2 and send. And it breaks.
Oh, yeah, for the end.
That's fair. Yep, I made last minute changes and it bit me in the butt. All right, so this is a required end. Again, if you try and consume something and the schema is slightly different from the way you're trying to consume it, it will tell you, and it will tell you quite verbally. Awesome, there we go. So we passed in 2, and you can see of all of the things that we got back, we only return the ones that were divided evenly by 2. Sound good? Cool. That is kind of the initial, how does this work setup before we start moving into other more complicated objects, hooking up a database, doing all the fun things that you're going to need to do if you ever have a project that's like not just showing you numbers. So if you have any questions about this, or like want to get, you know, some philosophical things out of the way about GraphQL, now is the time. Feeling pretty good so far? Awesome, let's do it. So let's set up our database. I'm gonna jump through this a little bit right now. This is a lot of Spring Boot stuff. And I will go through how it's all working a little bit, but I'm not gonna spend a lot of time on it unless we have some specific call out here. So we're gonna hook up to a database, we need a database, right? Great. Let's go look at our Docker Compose that I have set up here. So I'm going to use a Postgre database that's containerized. It's just running in the background for us. It's going to be available on my port 5432 right here. And it is running the Postgre 14.7 Alpine Docker image for us. It's going to have a database of Postgre that it creates, a user and a password of Postgre that it creates. And we are going to tell it that it should store its data on our local mounted host of Postgre data, which, as you can see right now, does not exist in our current directory, but it's going to exist in a second. So there are other fun things that we're going to hit here in a second. I'm going to keep those commented for now. For now, we're just going to start up this Postgre database. Sound good? All right, so we're going to run Docker compose up. All right, it's ready to go. Oh, now it's ready to go. Super quick. You can see that it created this Postgre data for us, and you can see it's running on 5432. We're now ready to connect. If you're in a real environment, you're going to be connecting to like an RDS on AWS or some database that is available somewhere. So let's figure out how we connect to it in our own stuff. I didn't show you this earlier, but this is the build.gradle. That's the wrong shortcut. This is the build.gradle file that gets generated for us. And if you're familiar with Maven or NPM or any other kind of like dependency management system, we're just defining all of our libraries and their versions that we're going to consume for that project and kind of keep in line here. We have a bunch of Spring Framework ones, GraphQL, Web, Validation, Lombok, which I haven't dug into much yet. I'll show you some Lombok annotations here in a second. It's divisive. Some people really like it, some people really don't. That's okay. I do. And then we have some test implementations, which we're not going to get to right now. I would normally test drive a lot of this stuff. However, we have very limited time for all of the stuff that I wrote in this README, and we might need to cut some of it short anyway. So we're not going to do that today. So right here, you can see under DB, I am going to uncomment some of these fun things. Let me go through these, not in order, because I have them in a weird order. Implementation, Spring Boot Starter Data JPA. It's going to give us all of our kind of data libraries that you would use to connect to a database in Spring Boot and set up all your kind of like hibernate mapping or JPA mapping behind the scenes to create entities. We will hit that in a second as well. The PostgreSQL drivers, because we are running against PostgreSQL database, very important. And then right here is Flyway core. If you guys don't know what Flyway is, it is kind of a infrastructure as code type thing for Flyway or for databases. Basically, every time we deploy, we are going to set up a set of scripts, and it's going to go look inside the database and be like, hey, have I applied these scripts to you yet? And if the answer is yes, it's going to be like, good, we're great. And if the answer is no, it's going to apply them. If the answer is yes, but different scripts, it's going to explode. So hopefully we're not going to do that this time. However, let's just jump in and say, hey, I already have some kind of thing defined. We are going to work with two objects right now. They're going to be very, very simple. The first one is going to be a person object. That person's going to have a name and an age. And then the second one's going to be an address object, which is going to have like an address string and then a state in there. We're not even going to make a state of enum. It's just a freeform string. You can invent any states you want. And then we are going to have a many to one relationship between addresses and person. So a person can have as many addresses as they want. And we will see what that looks like at the entity level in just a second. So how that looks here is if I go to my source main resources, let's first connect to our database. So we'll go to our application YAML that has all of our config in it that we talked about earlier. Let's uncomment some of this fun stuff that you've been like itching to get to here. Data source, fairly straightforward, username, password, driver class, and the URL to actually connect to the database. Not going to go into this super in depth, but this is what trying to consume an environment variable looks like in Spring configs, and then the colon, and then this is your default value. So we don't have any of these defined. I could have made it simpler, but this is usually how I set it up anyway. So we're going to be connecting using that Postgre username, Postgre password, and Postgre database that you see right here. It's going to be on localhost 5432, and we're using that PostgreSQL driver that we talked about as well. This will connect it and just make it our main database connection for us. We don't have to do anything else on the Spring Boot side to do that. Then Flyway is just going to basically write on the coattails of everything we just did for spring.datasource. And it's going to say that it is enabled. It's going to use the URL, password, user, and driver class name that we defined up here by just referencing spring.datasource.whatever variable we just talked about. All right. Uncommenting that and uncommenting the stuff in our build.gradle will set everything up for us. If we started up and that was not like running in the background, we would fail to start our application, but because we ran Docker Compose, we should be good to go. Now, when we do run it, because we have Flyway enabled, it's going to look in a very specific place in our source resources to look for any SQL files that we do want to use as migrations that will be applied when it starts up, kind of that infrastructure as code stuff that I talked about before. So that is conveniently located in source main resources, DB, working with the database, /migration. And inside migration, we have one here, some very complicated SQL where we create a person table and an address table. And that person table is going to have an ID, a name, age, secret info. I forgot about the secret info. It's very secret. That's going to show you a feature of GraphQL in a second here. And then address, like I said, person ID, address, and state. The person ID is a foreign key to person ID. So that's all we need to set up. Nothing more, nothing less. It's not too bad. We will see that shown in the logs when it actually sets it up for us. So before we start digging into actually consuming any of that stuff, let's make sure our app actually starts up and I didn't just like say it was going to work a bunch of times and then it doesn't. JPA show SQL is a way that you can tell JPA to show its SQL when you are running, like when it generates the SQL and runs it behind the scenes. We are going to use that in a second once we get to the n+1 problem. Yeah. Okay. Yeah, I didn't want to pop like pollute our console for now, but it does look like we started up. We are ready to go. If we kind of look up here, we can see some Hibernate stuff going out. We can even see some Flyway stuff where it says migrating schema public, version 1 init. And it's now at version 1, successfully applied 1 migration schema. So we know everything went there. Flyway schema history was created for us. If we wanted to connect the database directly, or sorry, like a database visualizer of some kind, like dbeaver, directly to that Postgre container, we could, and we would see all these tables created in the background for us. So now that that is all created and we can connect to it, how do we actually consume that from Spring Boot and start making facsimiles of the database objects inside, inside of our project? Let's go to our Java classes again. And there are a few different ways to do this, but this is the way I've kind of settled on over the past few years that I like a lot. I just have a DB in here and you see some very familiar things, person and address. So let's start with person. So I have a lot of this commented out because I had those libraries commented out in our build path. So let me uncomment everything. So inside class person, you see a whole bunch of fun annotations here. Those are all Lombok. I'll get to those in just a second. It's fine. But we have a public class of person. Person, you can see, has a few annotations that are straight out of the Spring JPA library. So one's going to be labeled our ID. ID is a generated value of some kind. It's going to generate that for us on the database level, so we don't even need to do anything. There's a UID type with string name, an integer age. We have some secret info that's just going to default to a string that says secret here. And then we have some addresses, and this is a little bit further into the Spring JPA ecosystem that I'm probably going to dig into right now. But this is how you would set up a one-to-many relationship with something else that controls the relationship. So because address has the foreign key to person, it controls the relationship technically. But we're setting it up right here where I can get addresses if I have a person object, or if I'm in the address object, I can get the person it's related to. All right, again, fairly simple. ID, generated value ID. We have a string address, we have a string state. Most of the stuff would usually be private, but I didn't want to clutter up the screen. And then down here, you can see that we have person that it is referring to. It's a many to one because you can have many addresses to one person. And they're all fetch type lazy. That's important here. If you guys don't know the difference between fetch type lazy and fetch type eager, basically, if I were to go get a person and it has 3 addresses related to it, if our fetch type is lazy, I would just get the person and I would run NoSQL related to addresses in the background. And then once I call person.getAddresses, it would then go run the query to get all of that address information for me. That is typically what you want to default to when you're working in Spring Boot with a lot of these things. I have rarely found a time when you want to say, yes, get everything eagerly all the time, no matter what. Usually you want to default it as lazy, and then you can kind of figure out ways to override that if you need to for efficiency's sake later on. Okay, like I said, probably not going to go into that a lot more. Lombok is fairly simple. We're generating a 2-string method, a getter, a setter for everything in here. So address, state, ID, person all have getters and setters. A builder, which is just, I call my class.builder, and then I can build an instance of the class pretty easily by providing it values, and then call .build at the end to actually instantiate it. But no args constructor and all args constructor, and at entity is the actual JPA annotation that lets us know this is a version of a table in our database. Okay, that was a lot. Sorry. Any questions on any of that? We haven't actually done anything with these yet, but they are made to like match up there. Ideally, you wouldn't need to do all this, but it's way better than it was like 10 years ago. I promise you. Cool. All right, so along with most of our different entities that we're going to make when you're using Spring JPA, you also need a way to like interact with the database once you have those. So I can make a new person object, but then what do I do with it? How do I save it? How do I delete it? All that kind of stuff. That is where the repository objects come in. So if I go look at my person repository, it's very simple because if anything in this world is magic, it is the Spring JPA repository interface. Spring JPA repository interface, you basically just say, I want to make a repository. It extends my entity object that I care about, and then I give it a second thing, which is the ID type of that. I honestly don't know why you need to provide both. I've never looked into it. It seems like you should only need to provide one, but whatever. So you just make an interface, and it will spin up and create a version of this person repository and throw it into your bean pool for you, so you can inject it everywhere and use it. And it also has like a bunch of base methods on it that you can consume, which we'll see in just a second. And then also you can just like write things, and it will understand how to run, which we'll also see in a second. It's very, and I don't question it because it would make my life harder. So We have person repository. Like I said, we're just going to use the base methods on the person repository. We're going to like save the person. Not a lot complicated there. Just know that I need to inject the person repository, call repo.save and pass it a person object. It'll work. We're good to go. The address one, we will hit in a second, but I'm going to go ahead and uncomment it. So we're ready for that. This has one magic method in it that will hit. Okay, so we have a person, we have our address, they are ready to go. Now we need to actually start like creating these things and doing something with them, right? So we are going to go back to our GraphQL schema where everything started, and all of the stuff that you just learned, we're gonna get rid of it. Sorry. Instead, we're going to use person queries. And the reason I had to get rid of the old one is because when you're setting up your GraphQL schema, you can't have multiple definitions for your query object. So this type query here, there can only be one of those. It's like Highlander. You cannot define that in multiple files and expect it to work. It'll blow up when you start up your app. You need one query type and all of your queries defined in there. It's a little annoying. I don't know why they don't let you do that. But we have the query, and then we're going to declare a couple of types. So before we dig into the queries, let's go look at some of our types here. Type person and type address. Seems fairly familiar. ID, a required ID, name, a required string, age, a required int, and addresses is a required address collection. Addresses has address and state, and again, address is just that string of whatever we want to put as the address string. Those types are fairly straightforward. Don't pay attention to this guy right now. Then, if we come up to our queries, we're going to see some different ways that we're going to interact with these. And again, let's just kind of simplify some stuff for us starting out. So first things first, we're going to have a way to get all of the people that exist. We're going to have a way to get one person that exists by passing in their ID. And then down here, remember when I talked about mutations, how we actually create or change data or do all those fun things like a post or a patch. That is what we're going to define down here as a way to create a person. And then when we do this, we need to specify some input types. Okay, so things get a little bit more complicated. Input types are any type that's not like a primitive GraphQL type, if you will, that you need to be able to pass in. So down here, we have a create person input type. So when I create a person, I need to be able to find a name and an age, but I don't need to be able to find like an ID because it's going to auto-generate that for me. So this is, they'll look very similar, but not completely the same a lot of the time. And then down here for addresses, I want to be able to create any addresses at the same time. And so I have to have a create address input object as well. This one does look basically identical to address, but inputs and types in GraphQL are different things. You cannot specify, like I couldn't change that to address because it would be like, hey, you tried to give me a type when I expected an input type. Make sense? Cool. So this was a lot to throw at you, but we're going to go look, and we're not going to just type it out and implement it together because I know that would be really boring. You already watched me do that with one class. So let's go look and see what it looks like here. Actually, no, right here. We have a different controller up here. So instead of this demo controller we were looking at before that looked like this, let's get rid of that guy. Now we are going to go look at our person controller. And our person controller also has a bunch of commented out code because we had to comment out that other code. But if I come down here, this is how we set up all of that stuff. So let's just take a quick tour of what's going on here, shall we? We have our person controller, it's annotated with controller. It knows it's going to serve up something on the web in this class. Next, we have AutoWired, which if you're not super familiar with dependency injection, just know that somewhere in the Spring Bean pool, it expects there to be an instance of a person repository object, and it wants to go grab that and make it available in this class. That's what's happening here. That's that interface magic I kind of told you about earlier. So we have an instance of person repository that exists. We're naming it repo. And then we can call the methods off of it because it exists and is ready for us to go. Then we have some familiar looking logic here. We have a query mapping. It's going to return a list of persons, of people. It's called people, which is similar to our queries that we defined right here. People returns a collection of person objects. And then you can see here, we're just calling one of the base methods on our repository, which is repo.findAll. And that's just going to give us an instance of every single person object that we have. Before we dig into anything else, let's verify that that's working, because I could also see this not behaving right away since I just uncommented the bottom code at the same time. Oh, yeah, okay.
Yeah.
1 second, please hold. Schema problem, item, it doesn't like that. Oh, yeah, that's fine. That makes sense. Remember when I commented out everything and said we're not using it anymore? I lied. Awesome. We started the application. We're good to go. Then what we can do is we can go to Insomnia. I have a people query right here. So this is where we start getting a little bit more into like, why is GraphQL even interesting? It is because I can go in here and define what I want my response to look like. Let's say you only care about people, you don't care about places. You don't want any address information. Great, get rid of it. You don't need to send that over the wire. You don't need them to go through the, they don't need to even spend cycles going to get that information for you. So if I were to call this right now, I would get back an empty array of people, which makes sense because we have made nothing for us to retrieve. So let's fix that first. We talked about mutations. So mutations are how we're going to make an object. You can see here that I say I have a create person mutation. It expects a create person object, and it's going to return our person that we created, which is nice. Come down here. Create person accepts a name, age, and then an array of addresses. That array must exist in some way. I could technically default it if I wanted to. So if someone didn't provide it, it would create an empty array for me. But right now we don't care. And then we have create address, which you can use to specify your stuff here. So we are going to look at how we implemented that in this guy. Not this one right now. Don't look at that. Instead, we have this mutation mapping. So when we use a query mapping to set up our queries, we use a mutation mapping to set up our mutations. It's named the same as our query. We give it an argument. And in this case, I cheated a little bit. I apologize. The person object that we created, or actually, yeah, this like database person object that we made it, I probably shouldn't have used it here, but because it has all the same fields and GraphQL kind of does the mapping behind the scenes for us, we don't care. So when it sends in our create person GraphQL object, it's going to be like, oh, okay, I found something. It's expecting a person object, going to make a new one and then stick all of the data in that matches for me. So we just have a person object. I would probably not do this in a production application. I would probably take this and like create a create person object, and then I would like map it to the database object, but we're not going to do that. So I get this create person object that's going to be filled with all the information that I sent into GraphQL. I'm going to say, this is a weird Spring JPA thing, forgive me. I'm going to get all of the addresses on that person, and then I'm going to set the person object on those addresses to be their parent create person object, because you have to, like, when you have two-way connections between JPA objects, they need to be filled out. The IDs need to be filled out. So if I tried to save this without doing that, it would be like, hey, you're trying to save an address object with a null person inside. I don't like it. So what we're going to do is just make sure all of those have their parent correctly assigned. Then we just call repo, save and flush, and we give it our person object that was just set up. All right. That was a lot. I apologize. I'm going to show it. And then if you guys have any questions, please let me know. This is still running. We didn't really change anything. So we're just going to go down to create person. And you can see things get, again, slightly more complicated here. We have our mutation instead of query, create person. It doesn't really matter. It can be called whatever I want. This is my part of the code. Then down here is where we start consuming the schema. So create person is the name of our mutation. And we had a create person object inside. I didn't name that super well. It's probably a little confusing. I apologize. This is the name of our actual like variable we're passing in. Then we define what it looks like. So my name is Gray. I'm going to make a gray person. I am 34, unfortunately. And we are going to make some addresses for me, okay? So you can see all of this is the part where I'm passing in arguments. And then what you see down here looks kind of familiar. This looks very similar to what we were querying inside just the people thing, right? It's because we've defined that when I call create person, I should expect to get back a person object in return in my schema. So if we go look here, mutation, create person, it expects a create person object, which let's be good about this and say that's required. And then it is expecting to return a person object as well. So I can define what fields do I care about that come back from that. So like, let's say that you want to make something, get the ID back so you can reference it later on. I could just say, only give me back the ID that I care about. Make sense? So let's see what it actually looks like and hope it works. Great. Okay, so we got back a create person, or this is our create person mutation, and this is the object we got in return. We have an ID for a newly created object. Its name is Gray, its age is 34, and it has an address of some street in Iowa. Sound good? Let's go ahead and make like 2 more. My wife Whitney is back there. Whitney is, let's say 29. And address is some street 2 in California. We live far away from each other. And we're going to send that, and Whitney is created as well. We now have 2 people in our database, which is the start of a great database. So now if I go back to people, let's just return every person again. And you can see that we do get back Gray and Whitney. Their ages, their IDs are all set up for us. Now, you'll notice a couple of things. 1, these are creating person objects behind the scenes. And if you remember right, there was a person object, or in our person object, we had some secret info. This can be things like when I was implementing this a couple of weeks ago for like a teammate directory type thing. That teammate directory has IDs that I don't really want to leak out through this GraphQL API. It needs to know them behind the scenes. It needs to save them in the database. However, I don't want that to be exposed to anyone else. I don't want them to be able to be like, hey, give me secret info, right? So because that secret info is not defined in my GraphQL schema, it is impossible to grab it out of my database object, even though I'm feeding my database object back through the controller all the way. All right, that's important because when you start getting to like a larger enterprise level and you start setting things up in a REST controller, what you see people do a lot of the times if they're used to putting together like smaller proof of concepts like this is they will take their database object, their database entity, they will retrieve it, and then they will feed it directly as the response. Don't do that in like a REST context, okay? That's a recipe for like giving away a lot of information that you don't want, either sensitive information or just like information that's going to slow stuff down. It just makes things pretty brittle. What you want to do is you want to set up a mapping layer to take your database object, turn it into some kind of API related object, hand that back instead, so you have the control. The nice thing about this is you don't really need to implement that set because the GraphQL library is doing it for you. If you don't have it set up in the schema, it doesn't exist. It's doing mapping for you behind the scenes, even though you're giving back a database object. Make sense? That is like one of the reasons I like this library so much is I don't need to set up all of the mapping stuff. It's doing it all behind the scenes for me. Cool. So if I were to try and retrieve secret info, which we know exists on this object, it's just going to yell at me, I think. Yeah, secret info and type person is undefined. How dare you? All right, as you can see here, like I said, we're not getting any addresses information. If I were to go grab this addresses stuff that I set up earlier, put it here, I would get back the addresses information. Let's say I don't care about the actual place. I just want to see who's all in what state. I can grab that information and it only gives back what I request, which is GraphQL. All right, that was a lot to start like jumping to working with database objects and more complicated things than just like an wrapper. Everyone feeling good? Yeah, any questions on any of that at all?
If you wanted to create some new mutation without actually returning anything,
Could I make my mutation return just something else if I wanted to?
just like say, let's say you're deleting
Mhm.
what would be you'd want to have it return back?
Yeah, you could return nothing. You could return the ID that was just deleted. You could return like what the object looked like as a snapshot when it was deleted. Yeah, anything you want. You could return 7. Doesn't really matter. Yeah. Okay, so that was a lot of fun stuff. Let's go look at retrieving one singular person because that's going to go into error handling, which is a lot of fun. It is 7:38. How are we doing on time? Doing okay? Sure. Yeah. Right. Yeah. Okay, cool. So person queries, we had people, which we just looked at. Let's look at person. We pass in one ID. We already kind of know what a parameterized query looks like. So let's go dig into this. Parameterized query here. It's going to look like this. Query mapping, which everyone's familiar with. We're returning one person object. It's named person because that's the name of our query. Has an argument of ID, which is a UUID. And then we're going to say repo.findById, which again is one of the built-in methods. Pass it the ID that was given to us. And then here is some fun Java optionals stuff, which is basically give me back This returns an optional person, if you look up here. So we're going to say either give me back the contents of this optional that is a person, or if it's null, throw this error instead. And we're going to throw this not found exception, no person with ID, whatever found. And we're going to format the string to include the ID. This is not going to work. So let's see it not work. Let's go to person. So you can see here we have person. It's set up fairly similarly. We have an ID. That ID is required. And then we have an ID that we're putting in our query variables here. This is an ID that no longer exists. Actually, before I do that, let's see it work properly. So let's get back gray, go to person, and let's set our value right here. Send, and we get back the full object that we requested, which makes sense. Now let's break it. Send. Okay, that doesn't exist. However, we went through all of the effort to make this nice not found exception, and we gave it even like a nice message that said that doesn't exist. However, you see none of this actually like given back to the consumer, right? All we see is internal error, and we see internal error here. If we went to our logs, we wouldn't think anything is a problem because our logs actually give us back the stack trace that we threw, which is somewhere way up here, and says not found exception for execution and no person with ID, whatever found. So the consumer's having a bad time, our logs are having a good time. That's not really what we want to happen. So how do you handle error logging or like consumer errors in GraphQL and Spring Boot? It's a little weird, to be honest with you. What you need to do is set up basically a bean that is going to handle all of that mapping for you. And I've just done like a very small version of that right now. So if we come into our controllers, I have this package called exception handlers, custom exception resolver. So the part that does the magic is it is extending our data fetcher exception resolver adapter, which is one of the most Java things I've ever heard. That is a Spring Boot like out of the box GraphQL library or class that you just need to extend, and then it knows that it needs to implement certain methods. I have made a quick map of some kind of throwable plus an error type, and an error type is a thing in our GraphQL execution. So when we are in here and we see this extensions classifications, this classification is an error type behind the scenes. So what we're saying is when a not found exception is thrown, I want that to map to an error type of not found. Forbidden exception is thrown, I want that to map to an error type of forbidden. And the code that actually does that is right here. So resolve to single error is taking in some throwable that has happened in our data fetching environment, which no one knows what that is. That's okay. And we make a GraphQL error builder, make a new error. This is just like very Spring stuff. I wouldn't worry about it too much. What you really care about is we are using our map we declared up above to basically say if the exception that was thrown is one of these types, use that error type, else use our internal error type. Then we come down here, get the message off of our exception that was thrown, and do all this fun stuff. So let's save that. Let's restart our app really quick. All right, we're up and running. And now if we run the exact same thing, you can see that instead of that terrible message we had before, we get no person with ID, whatever found, and you can see that the classification actually says not found. This is kind of an important step to make because you're not going to be able to rely on some of your default status codes that get generated behind the scenes by a lot of REST library stuff. Because we're always going to return a 200, you want to make sure that you always return something that's actually like user readable when you're working with errors. Okay, now, again, that was a lot of information thrown your way. Let's see, we covered setting up our database, our mutations, some exception handling. We can go a few different ways from here, and all of them are slightly more complicated. So I apologize, and I know we're kind of running short on time. So I'm going to give you guys a quick menu, and then we will just touch on it a little bit. First one is going to be adding easy pagination and filtering. Second one is the N+1 problem, which is a lot of fun. Or there's adding some security. Actually, I'm going to mix adding some security right now because that doesn't fit in quite as well. So do we want to talk about some pagination and filtering, or do we want to talk about the N+1 problem? N+1? Going once, going twice?
Sure.
N+1, great. Okay, so the N+1 problem is summed up like this. Typically, if you have like one main object that is going to be what you return, so in this case, we're talking about the person object, And that has some other objects that are child objects, in this case, the address object. In this case, we have one, but this can scale almost infinitely, or is unbounded, is a better way to say that. When I say, give me all of the people objects that I have, you're going to go great. And the default behavior of most implementations is going to be, I'm going to go to the database once, get all of my person objects. And then because we said that we are lazy fetching things, for every single person object I got back, I am now going to go call the database once more for all of the different address objects on it, or to get the collection of address objects that belong to that person. So in this particular case, let's make a couple of more people to make this fairly apparent. All right, Justin, you're going to be in here. Justin, you're also 29. Congratulations. All right.
Scandalous.
And Melissa. All right, we're going to add you in here too. Cool. So we have 4 people now. And if I go run this, you can see I get 4 people's worth of people back. Now, let's go see what's going on behind the scenes. So this should describe that N+1 problem pretty easily for you. And Melissa, this is for you. If we go look at our application.yaml, there was that fun JPA show SQL. So let's not break it, but instead uncomment it. And let's go here, clear everything, and run our app again. What we're going to see is when I call for this, we're going to see 5 Hibernate queries. And the first one is going to be, give me all of my people. And each one is going to be, give me all addresses that belong to person X. All right. Okay, so that ran. And then if I go here, hey, look at this. Hibernate, select all of our people. And then we have 4 where it's saying, give me all of the addresses where person ID equals whatever, because we have 4 people. Now, this doesn't take a long time on our side, but now let's say we have 1 million people. Now, instead of making 1 call for all of the people, we are making 1 plus 1,000 calls, which is where the N+1 problem comes in. The +1 is the initial call to get all your objects, and then N is all of the subsequent calls you need to make to populate the child objects from inside that. Okay? Do we understand the problem?
Yeah, it's not batching.
It's not batching, exactly. Now, the problem is that this happens all the time behind the scenes because people don't typically get to the scale where it is an issue. So you're like, I'll implement it the easy way. And unfortunately, implementing it the hard way is like nicer here, but it is still not as easy as just being like, go run free. So skill that, and I'm going to show you how you get around this. So there's 2 ways to do it. I'm going to go through them as quick as I can. And then if you want like more information, talk to me later, because I know that I've already used up most of my time. So we had our person controller here, and our person controller was doing this person thing right here. We are instead going to go to person controller 2, which is a more advanced version of our person controller. And I apologize, I'm going to skip over a couple of things really quick. And those are the paginated response stuff. I had intended to do those first, but just know that there is a paginated response object that we have set up both in our Java and in our GraphQL, and we're kind of wrapping everything in it. And then we are leveraging some of the out-of-the-box Spring JPA stuff to not really have to implement a lot of logic for it. So those exist. Our person queries, people with params, we're just going to be able to pass in a paging request object if we want, and a filter if we want. We're going to get back like a people wrapper that has all that pagination stuff in it. So let's just see that work super fast. Okay. People is not present when it is all in type clear. Okay. Person controller is fine. Person controller 2. That's our stuff with params. And then if I go to person queries, here we go. We said pass me a person filter, but we did not actually declare what that looked like. Cool. All right, that's wrong. So what this is going to look like is when we call people with params, it's a little more complicated. We can pass in a filter with like name and age to match stuff if we want to. And then we're getting back a bunch of different page information and a bunch of like all of our items that we care about. So in this case, I'm querying for all the people whose name is gray. Or here, we're gonna do this a little bit better. All the people whose age is 29. Which there's a lot of you. Nice. Okay, so we have three, basically everybody but me is who gets returned. And you can see all of the normal stuff that we talked about, plus some page information here. I won't go into how we did that, but we needed to work for N+1 problem stuff to work. So person or query controller 2. In here, you can see we have our person repo, just like we did before. We're getting some stuff. This is all about pagination stuff. We don't care about it. What we do care about is that we're returning basically all of our people that we care about. It's just getting those objects. So every time it's hitting those objects behind the scenes, it is doing that query call to get all the addresses that belong to that specific person. We have not fixed that part yet. This is how we're going to fix that part. So this is called the batch mapping annotation. And the batch mapping annotation is angry at me for some reason. Okay, now it's not angry anymore. So this is very, very similar to the schema mapping annotation that we talked about earlier. And that schema mapping annotation basically says, hey, I have an addresses that's going to need to be resolved somewhere in my GraphQL schema. And instead of getting one thing in, so we would normally hijack it by declaring schema mapping address that accepts a person object, we are now accepting a list of person objects for people. And you need to go grab them all in batches, and it does all this behind the scenes for you using that same schema mapping setup that we had before. So what you need to return is a map of persons and a list of address here. So for every person object, that's going to be a key, and the addresses that belong to it are going to be the value in our map. So you can see here we have our address repository. We use our magic find all by person in. So we're going to find all addresses that have any people related to this list that we've been passed in, collect them. And then I have this one little associate method that I'm not going to go into. If you've ever used Kotlin, you basically take a key and then associate it with some kind of output of a function. So we're just going to say for every person that was passed in, associate it with what we got out of that map. And then we return our map of person and list. This is something we could spend a whole lot of time on. I'm not really going to talk about it anymore, but so you can see what's going on here. We will kill this session, run it again. And now because we have that batch mapping set up, when we run this, you can see we only do one hibernate call and a second hibernate call. So it's mapping or it's batching all of them together by doing person ID in, and you can set how big you want that batch size to be in your annotation right there. It's a lot more we can cover. I'm here if you guys want to talk shop afterwards, but thank you for letting me talk at you for like forever. Let me know if you have any questions. It was a pleasure. The repository is up there. I'm going to push up another commit after this where all of this is uncommented and kind of working together, but I wanted to make sure that we kind of did it incrementally here. Yeah, if you download it, you have problems, I believe my LinkedIn or my email or all that stuff will be available and in the Slack channel. So, yeah. Thanks, everybody.
Yeah, I know we're kind of running short on time. I don't know if we have any quick questions, or maybe we can do that after. I'll just say that yes, there is that Slack channel that is actually DSM Web Collective. Like I said, you can come to me and I can hook you up, get you in there. I don't really know of any other good way. I think there is a dsmwebcollective.com site. I don't know that it has a link to it on their side. Other means to see this, you know, we post on our Facebook feed, our sites and all that, and we can post a link to repo there as well. Thank you very much, y'all, for coming out. Our next meeting, of course, we will do next month, the second Monday of that month. What the topic will be, don't exactly know yet, but please stay tuned and let us know if we can do anything else. Thank you very much, and thanks for coming out.
We do have a good call. So if you would, maybe about 1 or 2 on your way out. That would be good.
Nice job. Great talk.
It was a little long. Sorry about that.